Okay. So that we were discussing about the 6th unit, transaction. So transaction means the set of operations or group of tasks or series of actions which are logically related, right? So we perform this, like one user can perform this one in our database to access the data, right? So that example that day we have discussed. So today just go through it, like from to account X and Y. From X account to Y account, you have to transfer some money. Then what are the like operations you have to do, right? So this all are one that operation in the transaction. So in transaction we have some operations like which are we are doing in our transaction. So read operation, write operation, right? Commit, rollback. So read is for accessing the data or value from the database, right? And you can store that in the buffer memory. And write is from the buffer you have to store it again in the database. And commit is to store permanently, right? And rollback to undo. If you want to like undo it, that means then you can do the rollback, right? Rollback is for undo. And these 4 operations only we are having in our transaction. So some example that day we have discussed. So today I'm not going to repeat that again. So and some transaction property was there. We were discussed about this also. We have discussed like atomicity. So that means either success or fail. That means either all success or either fail, all fail. So in the like partial like execution is not allowed in the transaction. That is atomicity. Then consistency, that means whatever values are there, like before transaction and after transaction, that total should be same. There should not be any changes. Isolation, that means at a time only one operation, then one transaction has can be like execute, right? At a time you cannot execute 2 transaction. So that is isolation. And durability, and the durability, that is the consistency, like how long it is in your database. So the durability should be there. So if you do the commit, then it will be stored permanently in your database, right? Even after power off also it will not lose. So 4 properties of transaction, that are atomicity, consistency, isolation, and durability, right? So we have talked about that. So we are just skipping this all. Okay. Then next, states of transaction. In transaction we have some states, right? So 5 states we are having mainly. So when you begin your transaction, after that it will be in the active state. After active state, if you have like executed partially in that time, it is committed, partially committed. After you do the commit like operation, then it will be committed, then end. And when it is failed, say your operation is not completely done, that time from the active it will go to the failed state. After fail, what will happen? We have to abort it. After abort, that means your program will be end. So after abort, you can go back, like restart transaction, or you can kill the transaction. So these 5 states are there: active, partially committed, failed, aborted, right? So these are the states of transaction. Okay. So that day already we have discussed about this all state, like all phases. They have discussed what happens in the active state, what happened in the partially committed state, and what happens in the committed state, and what will happen in the failed state, and in the abort state, right? Aborted state, what will happen, right? So next we will start schedule. Schedule, that is the series of operations from one transaction to another transaction. So that is our schedule. That means when your transaction is going on at that time, so that operations in the transaction is some series of operations or set of operations, right? So that operations are when going on that time, the like after which operation will be done, so that series should be shown, right? So that whole series from one transaction to another one transaction, that is the schedule actually, right? So schedule, and it is used to preserve the order of operation in each of the individual transaction, right? So we have different types of schedule. So serial schedule, non-serial schedule, and serializable schedule. That schedule we can, that schedule anyway, you know, right? Schedule like our class schedule, at what time I am taking your class, or another faculty at what time they will take their class, like that. In the transaction also, like T1, T2, two transactions are there. So which transaction will take place at what time, right? When T1 will take first, next will be T2, or T2 take will first and T1 after that. So that schedule, actually we have to maintain that schedule. That is also very mandatory in our transaction. So in the schedule, you have that serial schedule, non-serial schedule, then serializable schedule. So in serial schedule, actually once you have finished one transactions, all operation, after that only you can start the next one, next transaction. That is serial schedule. But non-serial, in that time it is like maybe in between, you can say half you can do for transaction one, after that half you can do for transaction two, like that. So interference is there in between. So after that is non-serial, that is not serial, that, right? So non-serial schedule. Then another one is serializable schedule. So you have non-serial schedule, but that you can make serial schedule also by taking like, which will not affect, after changing also it will not affect the like a result of the your transaction or output of the transaction, right? So, so let's start with the serial schedule. So in the serial schedule, that's what. So once you finish one transaction, that means you execute the one transaction, after that only another one transaction you can start, right? So when first transaction completed means that whole cycle of the first transaction you have to finish, then only the next transaction will be executed, right? So first you have to finish the first one, then only next one you can start, right? So if we are having two transactions, say for example T1 and T2, so and T1 and T2 both are having some operation inside that, inside T1, that means T1 transaction is having some operations and T2 transaction is having some operations. So now how we can schedule that operations? So it can be two ways we can do, right? So execute all the operations of T1 followed by all the operations of T2. That means either finish all the operation of T1, then you start T2's operation, or start the T2's operation first, then you next you do for the T1's operations, right? So this is this example you can see in schedule A. We have mentioned this one, say for schedule as a schedule A. So here you can see for transaction T1. So we have finished all the operation for transaction T1. Is it visible whether the slides are changing or not? Okay. So here you can see the T1 transaction. For T1 transaction, so first we have done this operation, read operation, then this deduction operation, then write, read, and B for B this add operation. operation, then again write B. See, for T1, whatever operation is there, it is completed. It has done. So after that only for T2 transaction, it is starting. You see, after finishing the T1, we have started here read A for T2 transaction. So read A, then for this one addition, then write. Now this T2 transaction also over. So you either we can start the T1 first, then T2, after that T2, or you can, what you can do, you can first start the T2, see the schedule B. In the schedule B, we have started the T2 first. The operations of T2 transaction is done first. See, you can see here, read A equals to A plus M, this one, write A. These three operations we have done in the T2 transaction, right? Then we, after that, we have started this one. Read A equals to A minus N, write A, read B equals to B plus N, write B, right? This one we have done. So this is two types of schedule, right? That means two ways of schedule. You can do either first or second, whichever. But this is serial schedule. That means at a time, one transaction's operation can only done, right? So serial schedule means once if you are having, say, two transaction, in that case, first you have to finish the first transaction's operations, whatever operations is there. Then after completion of the first transaction only, you can start the operations for the second transaction. So that is our serial schedule. So now non-serial schedule, what will happen in non-serial schedule? So in non-serial schedule, so interleaved operation is allowed. That means in between we can, like we can do the operation of first transaction, and as after that we can do the transaction of second transaction also, right? So it is not serial. That means here in between one transaction operation is going on, in between we can like interrupt. We can again interleave and we can do for the transaction 2 also, right? So that order, but that order you should maintain. So here you can see one example we can take, C and D. See here, schedule C and schedule D, you can check. So read A for the first transaction T1. For transaction T1, we have done the operation like read A, and A equals to A minus N. After that, in between, what we have done, we can see right side, you can see for T2, that means for transaction T2, we can again do this operation. So read A. I think this some echoing. My voice is echoing. Oh, it is coming to me also. Oh. Mm-hmm. Right.
Hello.
Is it echoing still? So, di man echo? Samsung Hello? Is it still echoing?
Yes, it is.
Why this problem is coming?
I don't know.
Starting it was okay only.
It was fine for like for other people.
Yes, suddenly it came actually. Wait. Just stop it again and restart it. Okay. Is it visible? Uh, now the voice is okay. Okay. I think now we can start again. So we were discussing about the serial schedule, right? So that part is done. That slide is moving on. Okay. So non-serial schedule. We were talking about the non-serial schedule, right? So in this schedule, so we can interfere in between that. Once when your first transaction is going on, that means you are executing the first transactions operations. That time, some part of the first transaction you are doing. After that, maybe some part of the second transaction you are doing. Then again, the first transactions operation you are doing. Here you can see the example. So T1 is having the operations, this one, and T2 is having this operation. So here, T1, say in the T1, 2 operation it has done, right? After that, again 2 operation of T2 transaction. After that, again for T1 transaction, again 2 operations, write A and read B. These 2 operations have done. Then again for T2 transaction, write A operation, that is done. Right? After that, again this one. So this is one type of schedule, right? But it is non-serial schedule, right? So that same schedule again we can in this way also, right? Like 3 operation we have done in the left side, schedule D. Sorry, right side, schedule D. You can see for T1 we have done the read A equals to A minus N, write A. After that, for T2 transaction, we have done this, read A equals to A plus M, write A, right? After that, again, you have done for T1 transaction, read B equals to B plus N, then write B, right? So here you can see when we are doing like, say, after half of this and this, still we are not like our that result, whatever result is there, it is not affecting, right? The output, whatever output is there, it is not affecting, right? So anyway, we have read the A and A minus 1, this one we have done. After that, we are reading here, read A. After that, A equals to A plus M we have done. Then we have write the A, right? A. Then read B is there again. Read B we are doing here. We are reading the B only, right? Then here write A. Again you are writing this A. So B equals to B plus N. Then you have done the right B also. Then here also same thing. Once you have done this, then for T2 transaction you have done this one. Again then for T1 transaction, this operation you have done, right? So this is non-serial schedule. So you have to remember that 2 types of schedule, actually 3 types, but mainly there's serial, non-serial, and another one is serializable. So now we are coming to the serializable schedule. So in serializable schedule, when we use this to find a non-serial schedule to be like execute this, we can make the non-serial schedule to serial schedule. Say some like you have some transaction that you can make it serial schedule also, right? Say some non-serial schedule you are having, you can make it non-serial schedule, serial schedule also. Understood? By like doing some like you have to check it whether you can make that one without losing any or without changing the output of the result, output or result of the transaction. Then if you can say without changing the output or result, if you can make it serial like transaction serial schedule, serial schedule, then that is serializable schedule, right? A non-serial schedule will be serializable if its results is equal to the result of the transaction executed serially. Understood? So now say in the this is serializable schedule. So we have this one, conflict serializable schedule. So sometimes when we are doing the serializable schedule, that time it may conflict. So that operation will be whatever operations you are doing that time, some conflict may occur, right? The here some conditions are there when the like transactions operations are like conflicting, right? So these are the conditions. Here two operations become conflicting if the following conditions satisfied. So first is both belongs to the separate transaction. Say two operations are conflicting. When it will conflict if say, that conditions are like if both belongs to separate transaction. Say maybe that operation one is belongs to transaction one, operation two is belongs to transaction two, right? So they have the same data item. That means they are sharing the data. Say A, here they are say both are reading A. They are sharing the same, like using the same data, A or B, whichever. Either A or B, they are sharing say same data. Both are sharing, both are using. So they contain at least one write operation. When we are reading, that time we don't have any problem. The problem is in the write operation only, right? So right in the write, what we'll do, we are just updating our database, right? So problem comes in the write operation only generally. So reading is not a problem. So for example, your notebook, in your notebook, how many times you are reading, not a problem. But only one time only you can write, right? That's why the problem comes in the write operation, right? So here one example I'll just give. So here, so swapping is possible only if A and S1 and S2 are logically equal. That logically it should be equal. So here, if it is logically equal, see here, then it is not conflict. So here you can see read A and read T1 and T2. These are two transactions. So T1 is reading read A and T2 also reading A. But here there is no write operation. See. So here you can see read A, T1 transaction 1 just reading the A value, right? And transaction 2 also just reading the A value. If you like change also, like first you read the read for the transaction T2, then you can read the transaction T1. This read operation, that there is not a problem, right? The output will not change because you are not doing here any write operation or any update is not there. Only you are accessing the data. Either you are accessing for T1 first or T2 first, not a matter, right? So here S1 and S2 are same. So this is not conflict, non-conflict. We can say this is non-conflict. This schedule, this serializable schedule, this after swap also, that schedule is same. Before swap also the schedule S1 and after swap the schedule is S2. So after and before both schedules are giving the same result. So you can say this is non-conflict schedule, right? So here this schedule is non-conflict. But how the conflict will actually occur? Another one example we will take here. See here, transaction T1, in the transaction T1, read operation is there. A we are reading, but in transaction 2, they are writing the A. Right. So now you can see here. First, you have read the value of A. Transaction T1 read the value of A. After that, transaction 2 write that value. Right. Write that value A. After swap, what will happen? First, you have write the value of A. After that, you are doing the like read. So this both are not same. They both will not give you the same answer. The output or result may not be same. So in this case, the schedule is conflict. So this is conflict serializable schedule. So if this one is read operation, then there is no problem. But here it is write operation. You can see here. So first you have read it, then the set T1 has read it, A, and T2 has again write that. After that, T1, so first T2 started, T2 write the operation, this one, first done the operation, write operation, then T1 started the read operation. But we will not get the same answer. She say here, if the read operation say now the value is maybe A is having 6. So that 6 value T2 will write. So now this maybe here, now that is updated 6. So right, it is written 6. Now here you have to read the A, maybe some after some operation, or here you have written A equals to 5. You will get here that 5 only. You are reading that A now. So that both will not give the same result. So this is conflict schedule. Okay. So conflict equivalent. Another one thing also there. Conflict equivalent. How it. So one say in conflict equivalent, one can be transformed to another by swapping non-conflicting operations. So we have that non-conflict operation just now we have seen. So if the non-conflicting operation is there, then you can transform that operation to serial, like serial schedule. That's what conflict equivalent is there. You can make it conflict equivalent. So in this conflict equivalent, that means that non-conflicting operations are there. Right? In the given example, okay, we have that example. S2 is conflict equivalent to S1, or S1 can be converted to S2 by swapping non-conflicting operations. And two schedulers are said to be conflict equivalent if and only if they contain the same set of transactions, and if each pair of conflict operations are ordered in the same way. That means both are the same way they are having their operations. So if for transaction T1, if they are reading, then write, they are doing the same way. If the transaction 2 also same operations are there, then that time you can see like two schedule are said to be conflict equivalent. So like our that read operation, right? So here we can see this one. Say in this example, conflict equivalent, one can be transformed to another by this one. See here, non-serial schedule we are having. So read A, then write A. We have done the read of the A, then we have write it. Then again T2, read A, then write A. Then read B, write B, then read B and write B. All are having the same type of, both are having the same type of like operations, right? Read A, write A, read B, write B. Here also read A, write A, read B, write B. So this we can do by serial schedule also. See, read A, read B, read A, write B, A, read B, write B. And for transaction 2 also you have done, right? Read A, write A, read B, write B. So this is, see here you can see this is conflict serializable. So schedule C2 or S2 is serial schedule because all the operations of T1 are performed before starting any operation of T2 in this operation. So here this one is done after T2's operations are done after finishing the T1's operation only, right? Schedule S1 can be transformed into a serial schedule by swapping non-conflicting operations of S1. So that already we have done. After swapping of non-conflicting operation, the schedule S1 becomes like this. So here we are having this one, right? So after this is non-serial schedule. So this we can like transform to serial schedule. So that will not change any of like results. So S1 is conflict serialized. That means we can say this one is conflict serializable. This is serializable schedule. So this we can make it serial schedule, right? This is non-serial, but we can make it serial schedule. So that's why serializable schedule. Understood? Okay. So this example I have done. Now view serializability. So some another one schedule. By view, by seeing, you can see that it is like a serializable, but sometimes it may not be, right? Maybe you cannot just do the serializable. You cannot make it serializable, right? So if schedule is conflict serializable, then it will be view serializable. So if your schedule is conflict serializable, that means when you are making it serial schedule, that time you are not losing any data. That means output is same. Before making say non-serial transaction and serial transaction, when you are making, both are getting the same result, then that is conflict serializable, right? That schedule is conflict serializable schedule, right? So if it is conflict serializable schedule, then it will be view serializable. So that also another one thing. Then the view serializable which does not conflict serializable contains blind writes. Then view equivalent. Two schedules say we are having, so that S1 and S2 are there, and they are said to be like a view equivalent if they satisfy the three of like conditions: initial read condition, update read, then final write. These three conditions, if they follow or satisfy, then that schedule is view. Okay, so here initial read. In the initial read, what will happen? An initial read of both schedule must be the same. So in the starting, read must be same. So if transaction, say here A, first they are reading A. So here what they are saying, schedule A and schedule B, schedule S and schedule S2 in both. Is it audible? Okay. No, I was hearing some outside sound, so only I just asked. Okay. So initial read in the what happens? Both the schedule must be in the same first. Okay. Initial read. So suppose two schedule S1 and S2 you are having, and S1, if a transaction T1 is reading the data item A, then S2 transaction T1 should read the A. That means if T1 is reading A and T2 is reading after that, see T2 is writing, T1 is reading. In the schedule 2 also, T1 is reading only, right? Doing the read operation only, and T2 is doing the write operation. Whether it is earlier or later, but transaction is doing the same operation for same transaction, right? So for T1 read operation, here for T2 write operation, and same in schedule S2 also, for T1 read operation and for T2 write operation. 1 second, actually my laptop is out of charge. Just wait a minute, I just charge it. Can you hear me? Okay. So we were discussing about the view serializability, right? And the view serializability, 4 or 3 conditions are there, right? So we can say that two schedules are view equivalent if they satisfy these 3 conditions, right? Like initial read, update read, then final write. So in initial read, say we are having 2 schedule S1 and S2. So in that case, if T1 is reading A means in the schedule S, then in the schedule S2 also, the T1 has to read A, not right. So here for T1 also it is read for S. See in this side also T1 is having read operation. And T2 is having write operation. Here also T2 is having write operation. That means they are not in the schedule, they cannot change the operations. Same operation they have to do, right? So here also read, here also read for T1, and for T2 here also write is there, here also write is there. So above 2 schedules are view equivalent because initial read operation in S1 is done by T1 and S2 is in S2 it is also done by T1, right? In the both schedule read operation is done by T1 here also, here also. So next is update write. Sorry, update read. In updated read, what will happen? See here we have the schedule S1, this one. So if T1, it should be TI. TI means here anyone, T1 or T2, anytime. So TI is reading A, which is updated by TJ. Then in S2 also, TI should read A, which is updated by TJ. That means here, say, you can see here, say, this one, T1 is, no, it is right only. So this one you can see, T3. T3 is read here. After read, it is updated by T2. So same, it should happen. So, but here you can see, read operation is done by T3, but that next update is done by T1, not by T2. But here in schedule S1, the write operation is done by T2, but here the write operation is done by T1. Understood? So the above 2 schedules are not view equal because S1 in S1, that means in this schedule, T3 is reading A updated by T2. That's what this one is read by when T2 updated, right? But here you can see this read operation done after this one only. T1 has updated after read operation, right? But if say here also T2 and here also T2, after T2 it is done read operation followed by this one, then maybe it was equal, like view equal, right? But here it is not done like that. Then final write. So a final write must be the same between both the sheets. So yes, if T3 has done the write operation, means here also that T3 has to do the final write, right? So in the schedule S1, so if the transaction T1 update A at last, then in S2 final writes operations by T1, right? So see T3, their final write is done by T3. So here also final write is done by T3. So you can see here the above 2 schedule is view equivalent. View equal, that means, right? Because the final write is done by the same, right? So here also final write is done by same transaction. Say T1 after T2 read, then right. Here also read is done, but after T1, then final write is done by T. So this is view equivalent, right? So The three conditions we have: initial read, updated read, then final write. These three conditions we have to remember to see the view equivalent. Okay. So here one example we'll take. So schedule as we are having. So read A, we can do this one. T1, read A and write A. Then T2, write A. T3, write A. So this is our operations for transaction T1, T2 and T3. So we have this schedule. So with three transactions, the total number possible schedule, so it is 6. That means factorial of 3. 3 schedules we are having, so factorial of 3. That means we can this way, this many ways we can do the schedule, right? So now, so T1, T2, T3, T1, T3, T2, like this 6 ways you can take the schedule, because we are having 3 transaction, so we can conduct our this schedule in 6 ways, like this. So you can see here for the first schedule, say for this one, we just check it for the first schedule. So here we are having this schedule. So read A, then write A, then write again A, write A. Here we can see the final write operation, right? So final write is done by T3. Here also done by T3. Here also it is done by T3, right? And read also, you can see the read also. It is satisfying the read also, like starting read is done by T1. Here also A is read by T1, here also read by T1. Or you can see the final write. In the final write A. See here also final write is done by T3, here also T3. Right? So here you can see final updation or data item first step. In both schedule, as someone's voice is coming, outside voice, please mute that. Okay, then initial read we are having. So in the initial read, what is the initial read operation in S is done by T1, and in S1 it is also done by T1. That's what I just say to you. See here, initial read is done by T1. Here also initial read is done by T1, right? So then final write. So the final write operation in S is done by T3, and S1 also. Here also it is done by T3, right? So the first schedule S1 satisfies all 3 conditions. So we don't need no need to check it, right? Another schedule. So hence we, view equivalent serial schedule is T1, T2, T3. You can say this one. That first one is you can take T1, T2, T3. Right? So that means this is view equivalent. Okay. Now we are coming to the recoverability of the schedule. So after losing our data or our operation, say if we are failed, that whole data we have to again recover, right? When we do the rollback, we have to recover it again. So that recoverability of schedule we have to study. So when we are doing some transaction, so we are maybe in between when we are executing, so our execution is not properly. So in between we got some crash of our hardware, some system crash, or maybe hardware failure, or some other issues like software issues or some like connection issues. Any type of issues may create some failure of your transaction. So that time what we have to do, we cannot update, right? But in that case, what we have to do, we have to roll back. Rollback means when you are roll back, that means we have to like go back to the initial stage again, right? Whatever update we have done, whatever execution we have done, that all we have to undo it, roll back, right? So, but when we are doing some So in middle only that crash or something happened, failure occurred. But till that, what sometimes we may like updated our values, we may produce some values, right? That all now again we have to remove it, roll back it. So the previous whatever values are there, we have to keep keep that value again, right? So maybe initially that transaction amount, say your account is was having like 5,000 money. After deduction, say we are like just transferring the money. That time in that middle, that till that it is deducted. Say 3,000 is deducted. Now your account is having 2,000. But if the failure happen, it is not success, means again we have to recover that value, right? 5,000, whatever initially it was, we have to put that value again. So rollback is needed for that, right? So here we are just giving this that only recoverable, because there are different types of recoverable like schedule is there. We can recover that schedule by using cascading rollback operation. So here in this example, say T1 and T2, we are having our transaction. So T1 read A, that means when you are reading in our buffer memory, buffer space, say you got 6,500, right? So after that, you have done this one, A equals to A minus 500. That means, so here you can see 6,000 minus is done. So 6,000. So this side you can see till we update or commit our database, that value is like same only. After finishing this all only, this final database like update. So here you can see this read operation. These all have done. Write A. Now you have written in the A 6,000. Right. Now transaction 2 you have done. So read A. This one read A. Then you have plus that plus here, instead of maybe 500, you have done 1,000 plus. Then you have read that value and commit. Say here you have committed. If you do commit, then you cannot do the rollback actually. So final rollback here itself you should not do the commit. After finishing this also only you can do the commit here. So here you see in this case what problems will occur here. You can see now you have commit here. You have committed this operations here. So it's stored in the A 7,000. See, for T2's buffer, it is stored for A, it is stored 7,000. Right. But now some failure occurs, right? In the transaction T1, some failure occur, failure point. So now you can see here on 500 only they have detected, but here it is added 1,000. But see the database, you can in the consistency is not there. You can see in the earlier time 6,500 it was, but now it is 7,000. It should not be 7,000, right? It should be again 6,500. Then only that I can say that consistency, right? We have to check the consistency after finishing that transaction and before finishing that transaction. So here T2 should also that's what rollback. If you do the rollback, if failure happens, now you have to do the rollback. But already commit is done here in the transaction 2. So we cannot go back to the this all. We cannot recover it actually. So here, how you can do this? See here again. I'm just showing you to remove that problem. How we can do the commit operation here. You can see for transaction T1, you can see read operation is there. So you have done this on this. Then you have committed A. Right A you have done. Then you have committed. Now here you can see read A and 1,000 here it is site also it is done. No, here actually till this one is done. Here after that only for T2 also this commit is done. commit is here also it is done. So 1000. Here no failure is done actually. Here commit already done. So this side there is no like commit is done. After that it is over only. Final write is done. Right. So here the role failure was done. So after that it is confirmed. Failure done means what? Again it have to go to the starting again, right? But here this side, see here the problem is, say here it is not committed, but here some failure happens. So what will happen? So it will again roll back. It means it will again either restart or delete that transaction, right? That means end that, kill that transaction. But this side already committed means it is stored, right? This one. But again, when you are restarting, again this will repeat now. Instead of 6,000, it will read 7,000, right? Because it is already committed and permanently stored. That was the problem actually here. So when a failure, if some failure occurs, so that's why when you finish D1, that commit that itself at that time. Here in the cascading rollback, they are doing like this. Okay. So then irrecoverable schedule. Another one is irrecoverable schedule. So in the cascading decision, recoverable with cascading rollback. And then next one is irrecoverable schedule. And in this schedule, say if T2 reads the updated value of T1, T2 reads the updated value of T1, then T2 committed before T1 commit. Okay, here you can see again T1 read and T2 that buffer, all these thing will happen. Then T2 you are having after this one. See again failure is done. So here it is failure happens. So after that committed. Failure happens when it will again restart this all. After this one finish, then only T2 will commit. Okay. Then we are coming to the failure classification. Okay, this will start in the next class. Failure classification, that is the like system class or disk failure, transaction failure, like syntax error or something. That all like failure will come. We have that all we can classify in some categories that we'll discuss in the. So today's class is going to be over. I'll just take the attendance. Till that.